Okay, welcome back. The second thing we're going to do, the second big topic inside this section, is using determinants to help us find inverses. So one connection that we already know that relates inverses to determinants is that if the determinant of a coefficient matrix is non-zero, then that's a guarantee that the inverse of that coefficient matrix will exist. The same can be true in reverse. If A inverse exists, then the determinant must not be zero. What we're going to do to use determinants as part of the procedure to find inverses is we're going to construct a new matrix called an adjoint, and then we're going to relate the adjoint, this new matrix adjoint, we're going to relate that to the inverse and the determinant. We're going to combine them. This adjoint matrix is constructed using a type of ingredient that we've already been working with. It's constructed through a bunch of cofactors. It's actually just a matrix of cofactors of the transpose of A. The notation for it looks terrible. The ij entry of the adjoint of A is equal to -1 to the power of I plus j times the determinant of AJI, where AJI is AIJ transposed. You switch the row and the column index. Just like if you go from matrix A to matrix A transpose, what you're doing is you're replacing row 1 with column 1, replacing row 2 with column 2, and so on. You're just replacing all the row indices with column indices. So anyways, you can rewrite that thus as the determinant of A transpose sub ij. So it is, like all instances of this ij notation, it's not what you're used to seeing. You probably don't like to see subscripts and superscripts combined in the same expression. You'll get used to that with more courses that have this type of notation, but it really isn't that bad. It's just not what you're used to seeing. That's why it looks bad. Our recipe for finding the adjoint of a matrix A is, the first thing we're going to do is we're going to transpose A. And the second thing we're going to do is we're going to calculate all of the cofactors of that transposed matrix. This might be a lot of work. If A is 2 by 2, we're going to have 4 cofactor calculations. For a 3 by 3 matrix, so a 3 by 3 matrix has 9 entries. Each of those entries has a cofactor, so I'll have 9 cofactor calculations. For a 4 by 4, I'll have 16 cofactor calculations. Then we'll just put them all together. So the 1 cofactor of the transpose becomes the 1 entry of the adjoint of A. We'll start with a 2 by 2. Find the adjoint of A. So step 1. I'm going to show you a bookkeeping device that you can use to prevent mistakes from being made. And if I don't do what I'm about to show you, I will make mistakes. So step 1 is not actually, see this recipe, find A transpose. Okay, that's step 1. So find A transpose. There's a hidden step. I'm not going to keep the ingredients list, or in the recipe list, but it's an important step. So the transpose, I'm going to replace row 1 with column 1. So 3, 11. Replace row 2 with column 2, 7, 2. Okay, now here's the part that I'm going to do. I'm going to take this, I'm going to hide it. I'm going to hide it because I might accidentally look up and use it to calculate my cofactors. Step 2, cofactors of A transpose. And after I'm done, I'll unhide it. I'll erase it. So we have the cofactor C11. So recall our formula for cofactors. We have -1 to the power of I plus j, so -1 to the power of 1 plus 1, times the determinant of the submatrix A11. So that's going to be -1 squared times the determinant of, when we eliminate row 1, column 1, we're going to get just 2, determinant of 2. So we get 1 times 2, which is 2. The determinant of a single number, of a 1 by 1 matrix, is just the entry of that matrix. Okay, now we're going to get the C12, or C12 rather, C12 entry. So we'll have negative 1 to the 1 plus 2 times the determinant of A12. So negative 1 to the power of 3 times the determinant of the matrix that we get when we remove row 1, column 2. So we're just left with a 7 when we do that. We'll have negative 1 times 7, which is negative 7. Okay, now the C21 cofactor, so negative 1 to the power of 2 plus 1 times the determinant of A21. Or I guess I should call these A transpose 1, 1, A transpose 1, 2, A transpose 2, 1. So we'll have negative 1 to the power of 3 once again. Now, what do we have? When we eliminate row 2, column 1, we'll have an 11. So we'll have negative 1 times 11, which is negative 11. And then the last cofactor, C22, we'll have negative 1 to the 2 plus 2 times the determinant of A22 transpose. So negative 1 to the power of 4. Now we're going to cross out row 2, cross out column 2. We just have a 3 left on the top left. So positive 1 times 3, we get 3 for that one. Now we put these together in step 3, construct adjoint of A. Okay, I'm going to unhide A. I don't need it for the next step. I'm going to unhide it. And again, the only reason I hid it was that I didn't look up at the very top and make my sub matrices by crossing out A instead of A transpose. Like say halfway through a calculation, change my mind about which one's which. So adjoint of A is going to be equal to so 2, negative 7, negative 11, 3. That's it. Oh boy, now we have this fun thing to do. This adjoint will need 9 cofactors. Three by 3 matrix needs 9 cofactors. I didn't mention this, but it's worth noting that it's acceptable to find all the cofactors of A, not A transpose, construct that matrix, and then transpose that. So you can do the transpose at the beginning, or you can do the transpose at the end. They'll be the same. I'm going to just continue using that recipe. I'm going to start by transposing A. So A transpose is equal to, the first row becomes the first column, 1, 2, 3. The second row becomes the second column, 0, 4, 5. And the third row becomes the third column, 0, 0, 6. Now I'm going to hide A so I don't accidentally look at it. So that was step 1. Step 2, find all of the cofactors, all 9 cofactors. Okay, so starting with cofactor, and I'm going to have to write small to fit them all here. C11, negative 1 to the power of 1 plus 1 times the determinant of the submatrix A11, or rather A transpose 1, 1. So that'll be negative 1 squared times the determinant of, so I'm going to I'm gonna put the whole matrix there. 1, 0, 0, 2, 4, 0, 3, 5, 6, and then cross out what I need to cross out. So I'm going to cross out row 1, I'm going to cross out column 1. So that's going to be -1 squared is 1 times the determinant of 4 times 6, down product minus up product minus 5 times 0. So we'll have 1 times 24, which is 24. So that's my first cofactor. Now I'm going to get my next cofactor. I'm going to put some separations between them so they're easy to distinguish from each other. And we'll have to continue on the next slide for sure. Okay, so C12. That's -1 to the 1 plus 2 times the determinant of A transpose 1, 2. So -1 cubed, and I'll make a copy of the entire matrix. 1, 0, 0, 2, 4, 0, 3, 5, 6. Okay, and this time we are replacing, or we're not replacing, eliminating row 1, column 2, and taking the determinant of what's left. So we're going to have -1 multiplied by 2 times 6 minus 3 times 0. So I'll have -12 for that cofactor. Okay, now the next one, C13. It's a lot of work. -1 to the power of 1 plus 3 times the determinant of A transpose 1, 3. So -1 to the power of 4 times the determinant. I'll make a copy of the entire thing. 1, 0, 0, 2, 4, 0, 3, 5, 6. Okay, and this time we're eliminating row 1, column 3. And we'll have +1 times the determinant of that 2 by 2. So 2 times 5 minus 3 times 4. We'll have 10 minus 12, -2. Okay, now we'll keep going. Let's get the next one, C14. Oh, no, I'm a liar, not C14, C21. We're done the first row, now we're going to the second row. So C21, -1 to the power of 2 plus 1 times the determinant of A transpose 2, 1. So -1 to the power of 3. Make a copy of that matrix. 1, 0, 0, 2, 4, 0, 3, 5, 6. And then we're going to hide row 2, column 1, and take the determinant of what's left. And we get -1 multiplied by 0 times 6 minus 5 times 0, which is 0. Okay, now the next one, C22, -1 to the power of 2 plus 2 times the determinant. Very mechanical. It's hard to get excited about this type of calculation. This is like very, very boring. Oh my god. So we have -1 to the power of 4 times the determinant of, okay. Even though it's boring, it's like therapeutic. It's very mechanical. You don't have to think. You don't have to like strategize. You just do. Row 1 is deleted. Column 2 is deleted. So you get positive 1 times the down product, 1 times 6, minus the up product, 3 times 0. So we just get 6. Now the last cofactor inside the second row, C23, negative 1 to the power of 2 plus 3 times the determinant of A transpose 2, 3. So negative 1 to the power of 5. Make a copy of the original matrix. Determine of A transpose, 1, 0, 0, 2, 4, 0, 3, 5, 6. And then we're looking at this submatrix. We eliminate row 2, eliminate column 3. So we have negative 1 multiplied by the down product, 1 times 5, minus the up product, 3 times 0. So we get negative 5 for that one. So 24, negative 12, negative 2. The first row, and then 0, 6, negative 5. And now we need the third row. So this is just continued from the last. So we had A transposed 1, 0, 0, 2, 4, 0, 3, 5, 6. So now we need the third row. So C31 is equal to negative 1 to the power of 3 plus 1 times the determinant of A transpose 31, So negative 1 to the power of 4 times the determinant. I would make a copy of that matrix. 1, 0, 0, 2, 4, 0, 3, 5, 6. So positive 1 times, okay, so we're going to eliminate row 3, column 1. Take the determinant of what's left. So we'll have down product, 0 times 0, minus the up product, 4 times 0, which is 0. Okay, now we do the next entry over, C32. Negative 1 to the power of 3 plus 2, determinant of A transpose 3, 2. So negative 1 to the power of 5. Make a copy of that matrix. 1, 0, 0, 2, 4, 0, 3, 5, 6. Eliminate row 3, eliminate column 2. So we have negative 1 multiplied by down product, which is 1 times 0, minus the up product, 2 times 0. So we get 0 for that one as well. And then we have the last cofactor we need to calculate for this example. Negative 1 to the power of 3 plus 3 times the determinant of A transpose 3, 3. So negative 1, oh, don't do that. Negative 1 to the power of 6. Make a copy of the matrix. So 1, 0, 0, 2, 4, 0, 3, 5, 6. So we're going to cross out row 3, cross out column 3. And we have positive 1 times the down product, 1 times 4, minus the up product, 2 times 0. So we just get 4. So put those numbers down here, 0, 0, 4. That'll be our adjoint. Okay, and so that's how to calculate adjoints. In the next video, we'll do something with these adjoints.